Hello and welcome. I am your host and speaker, Priyanshu Mishra, and I am Associate Data Engineer at Infometry. Thank you for taking the time to join us today. In today's webinar, I'll be talking about basics of PySpark. Feel free to drop questions on the topic or share your struggles and experiences during this live session. We will answer your queries through chats. Let's start this session. This session is organized by Infometry. We are a pure play data analytics company based out of Fremont, California, with our offshore development center in Bangalore, India. We came into inception back in 2010, and since then we have been offering domain-specific analytics solutions for high-tech, energy, life science, retail, manufacturing, and finance customers. Being a data analytics software service and solution provider, we focus on delivering predictive and prescriptive analytics solution, cloud data warehouse implementation, data governance, enterprise service bus, microservice-based integration solution, big data, cloud DevOps, Salesforce CRM, and product engineering, etc. Infometry has been an engineering and consulting services partner for companies like Informatica, Medallion, Snowflake, Tableau, Adaptive Insight, Looker, and many more. Infometry offers domain-specific analytics solutions for high-tech energy, life science, retail, manufacturing, and finance customers. In addition to the service, we have also developed more than 15 cloud connectors for IICs. One mentioned under Blue Blocks are developed and owned by us, and the rest are all developed by us only for organizations like Informatica, SAP DS, and many others. We have developed state-of-the-art analytics solution, InfoFiscus, which can be hooked to any on-prem or cloud CRM, ERP, or planning apps. InfoFiscus is 100% cloud-based pre-built analytics software developed using open architecture. InfoFiscus comes in three different levels: finance, supply chain, and sales and marketing analytics. We are delighted to announce the launch of the next generation InfoFiscus Sales Analytics Snowflake native application, which aims to streamline sales analytics for customers using Salesforce, Marketo, and Snowflake. That's our quick introduction, and now let's move to today's agenda. In the data world, we often deal with massive data sets that are impossible to process efficiently on a single machine. This is where PySpark comes in. PySpark is the Python API for Apache Spark, a powerful open source distributed computing system designed for big data processing. Sparks allow us to process large datasets in a parallel across a cluster of machines, enabling speed and scalability. In this session, I will guide you through why PySpark is important in modern data engineering, the core architecture and components of PySpark, fundamental concepts like RDDs and DataFrames, setting up PySpark on your system, optimization techniques to improve performance. This webinar is ideal for anyone looking to understand the fundamental of PySpark and its role in the big data ecosystem. Let's dive in. The digital world is experiencing a data explosion. Organizations collect data from multiple sources like customer interactions, IoT device, transactions, logs, and more. Processing these massive data sets efficiently requires distributed system. So the key reasons why PySpark is crucial are big data processing. PySpark handles data that are too large for a single machine by distributing it across a cluster. Let's take an example. A streaming platform like Netflix analyzes millions of views daily to recommend shows in real time. PySpark's parallel processing enables such workloads. Speed. PySpark uses in-memory computation, which is much faster than traditional disk-based processing. Let's take an example. PySpark can process gigabytes of data in seconds, which is ideal for real-time applications like fraud detection. Flexibility. PySpark supports various data formats and sources including structured data in SQL database, semi-structured data like JSON or XML, unstructured data like logs or sensor readings. Python integration. Python is a popular language in data science. PySpark enables Python developers to harness the power of distributed computing without switching languages. In short, PySpark bridges the gap between Python's simplicity and Spark's power, making it an indispensable tool for big data. Now let's discuss PySpark's architecture. Understanding the architecture will help you appreciate how PySpark manages distributed computing efficiently. PySpark architecture revolves around these layers. First one is driver program. The driver is the central coordinator of a PySpark application. It splits the job into smaller tasks and distributes them to worker nodes. It also collects the result back from the worker nodes. Second, Spark context. Spark context is the entry point of a PySpark application. It connects the driver to the Spark cluster in initialize configuration and manage resources. Third, cluster manager. The cluster manager allocates resources like memory and CPU to Spark jobs. PySpark can work with Yarn, Mesos, and standalone. Fourth, worker nodes and executors. Worker nodes executes tasks assigned by the drivers. Each worker runs executors, which are processing responsible for executing tasks and storing data. Fifth one is DAG or Directed Acyclic Graph. Every PySpark job is represented as a DAG. The DAG scheduler optimizes task execution by analyzing dependency and minimizing data movements. Sixth, Shuffle Manager. Shuffle occurs during operations like join or group by, where data needs to be redistributed across partitions. The shuffle managers ensure this is done efficiently. Think of PySpark as a factory assembly line. The driver is the factory manager. The Spark context is the communication system. The cluster manager allocates worker to task. The executors are the workers assembling the products. Let's move to PySpark ecosystem. PySpark extends its capability with a rich ecosystem. The first one is Spark SQL. It enables structured data processing using SQL-like syntax. For example, querying a large sales dataset to find the top selling products. Second is Spark Streaming. It processes real-time streaming data such as log or sensor data. Third is ML library, a machine learning library for classification, regression, and clustering. For example, building a recommendation engine for e-commerce. Fourth one is GraphX. It handles graphs processing and graphs parallel computations. Now let's move on to how to set up PySpark. So let's go step by step. So the prerequisites includes installing Python and Java and downloading Apache Spark. You can download PySpark using pip install PySpark. Then set up your environment, Hadoop, and then verify if the installation is done properly. You can use Jupyter Notebook for interactive coding. For large projects, integrates with IDEs like PySpark. Let's move on to Spark Context and Spark Session. Spark Context is the entry point for Spark functionalities in a Spark application. It connects to the cluster, allocates resource, and is used to create RDDs and manage data processing tasks. Spark Session is a new entry point introduced in Spark 2.2. It's a unified interface for managing different Spark functionalities, including Spark SQL and DataFrames. Spark Session effectively replaces Spark Context for most applications, as it offers more functionalities and simplifies code. In a typical PySpark application, you initialize a Spark session, which uses Spark context in the background to connect with the cluster. Now we came to one of the foundation concepts in Spark, RDD, or Resilient Distributed Dataset. RDD are immutable distributed collection of objects that can be processed in parallel. They allow Sparks to split data across nodes in the cluster and perform transformation on each partitions. So the key properties includes resilience. RDD automatically recover from node failure. Distributed. They are partitioned across nodes for parallel processing. Immutable. Once created, RDDs cannot be modified ensuring data consistency. RDD provides a reliable way to perform fault-tolerant distributed data processing, which is why they are essential to Spark. Importance of RDD in PySparks are important because they are optimized for parallel processing. They allow Spark to keep data in memory, avoiding costly disk input-output operations. This makes RDDs perfect for iterative algorithm where you need to reuse data multiple times. They are also fault tolerant, meaning if a node goes down, Spark can automatically rebuild the lost data. RDD operations. There are two types of RDD operations, transformations and actions. Transformations are lazy operations that define a new RDD from an existing one, such as map, filter, or a flat map. They don't compute result immediately. Instead, they build up a lineage or chain of transformations, which PySparks optimize and execute later when an action is triggered. Action triggers computations and returns result to the driver or writes data to external storage. Example of action includes collect, which brings the data to the driver, and count, which counts the element in an RDD. Transformations and actions together allow Spark to build a directed cyclic graph, and that is optimized and executed efficiently. RDD persistence or caching. It allows us to store an RDD in memory across operations. This is very useful in iterative algorithms where we need to use the same RDD multiple times. We can persist an RDD in memory, on disk, or both, depending on available resource. The common persistence levels are: first one, memory only. It stores RDD in memory. This is the fastest option, but requires sufficient memory. Second, memory and disk. It stores data in memory and spills to disk if needed. Third, disk only. It only uses disk which is slower but useful when memory is limited. PySpark DataFrames. So what are PySpark DataFrames? PySpark DataFrames are distributed collection of data organized into named columns. They are conceptually similar to tables in a relation database or data frames. It optimized for structured data, offering better performance than RDDs. It enables SQL-like querying, which simplifies the manipulation of large data sets. So the key features of PySpark DataFrames includes distributed, which means data is spread across a cluster of machines. Optimized. It is used Spark's Catalyst optimizer for querying optimizations. It is schema-based. Data is organized into columns with a schema. It is fault tolerant. It can recover from node failures. It is integrated with Spark SQL, allowing SQL queries alongside DataFrame's API operations. So now let's move on to how to create data frames in PySpark. It can be created from a different ways, like from RDDs. You can convert an existing RDD into a data frame, or you can read data from various file formats like CSV, JSON, Parquet using spark.read. You can also load data from a relational database. So what are data frames operations? So it includes select, filter, group by, join. So we can use select for retrieving specific column from a data frame. Filter, it applies condition to select rows that meets specific criteria. Group by, it groups data based on a column and perform aggregation operations like sum, average, and minimum. Join, it combines two or more data frames based on a common column. So why to use data frames? First is performance. Data frames are faster and more efficient than RDDs for structured data due to optimization by Catalyst and Tungsten. It is ease of use. Data frames provide a higher level API that is easier to use compared to RDDs, especially for SQL-like operations. Better memory efficiency. Data frames are optimized for memory management, making them more suitable for large-scale data processing. Interoperability seamlessly integrates with different data formats like CSV, JSON, Parquet, and even external data source like HDFS, S3, recent database. So what are the use cases of PySpark data frames? First is ETL. Efficiently transform a load large data set for processing and analysis. Data analytics. It performs aggregation, filtering, and data exploration for business intelligence and reporting. Machine learning pipelines. It uses data frame for data pre-processing, feature extraction, and cleaning before applying machine learning algorithm. Big data processing. Data frames makes it easier to process massive data set across distributed cluster with high scalability. So now let's move on to PySpark performance optimizations. Use data frame instead of RDDs. Data frames are faster and easier to use than RDDs for structured data. They are automatically optimized for better performance. Reduce shuffles. Shuffling data is slow. Minimizing shuffles by filtering data early or using better alternatives like broadcast joins. Optimize partition sizes. Make sure data is split into the right number of chunks. This helps balance the work even across all machines, improving performance. So that's the end of our PySpark session. We have covered PySpark architecture, components, and optimization strategies. PySpark simplifies big data processing, and I hope you are excited to explore its capability in your projects.
I request everyone to unmute themselves so that everyone can ask all the questions they have.
Yeah, hi Priyanshu. I have a question. What is the difference between a data frame and RDD?
Hey, hi, Aditya. So, the difference between RDD and data frames is data frame is a higher level API for structured data, but RDDs are lower level API for unstructured data. And data frames are SQL-like operations, but RDDs are functional API.
Okay, thank you.
Yeah, hi Priyanshu.
Yeah.
How does Spark SQL make data processing easier for a structured data set?
So, Spark SQL has SQL-like interface. It has schema enforcement. It has optimization, it uses Catalyst optimizer, and it even have unified data access.
Okay, thank you.
Hi Priyanshu, I have a question. So, what factor should you consider when deciding the partition size of a Spark job?
So, the factors you can consider are like cluster resource, data size. Like in data size, keep partition between around 128 MB and 256 MB. Then task parallelization, data screw, transformation types.
Okay, thank you.
Hi Priyanshu.
Yeah, hi.
Yeah, so my question is what is Catalyst optimizer?
So, the Catalyst optimizer is Spark SQL query optimization for frame. Sorry, Catalyst optimizer is Spark SQL query optimization framework that simplifies query executions. It even improves resolution and resource utilizations. It even handles complex queries with minimum users.
Got it. Yeah. Thank you so much. Thank you so much, Priyanshu, for this amazing webinar on PySpark. Is anyone there who wants to ask any questions? Please feel free to ask the questions. Okay. So thank you so much for this amazing webinar, and I hope everyone found this session really useful. And for more future webinars, please follow us on our website and social media profiles. Yeah. Thank you so much. Have a nice day.